Okay, let's continue. Julia's here, Robin's here, Richard is here.
I'm recording this for Anna. Stop, Rob,
I'm
stop.
putting it on this desk.
Sophie, where's Sophie? Okay, get your calculators out, get your notes out. You need both notes packets. We're finishing the old, we're starting the new. We're finishing the new. The test is tomorrow and Friday. It has been written. I will give you hints throughout the lesson today. I will tell you how to study, but you got to focus. We don't have time for this. I'm not in tutorials today. I have a meeting today. You have your test tomorrow. You have your test Friday. So let's focus. All right, I'm going to work some application problems. I'll tell you what part of it is on the test and what part isn't on the test. You need your calculators, get them out.
This is the
All right.
packet.
Page 34.
Get on page 100. Oh, yeah.
Okay, so you have been given an equation. So we need to understand what this equation represents. It is saying that the average height in centimeters, h is the height. This is function notation, and it is saying that h is a function of r. What is r? The distance in centimeters between the rows of grain. So depending on how far apart I plant my row spacing, r, determines how high my grains grow, h. So they have given you the model. Based on this model, what can you tell me about the graph of this model?
R will be X and H will be Y.
Okay, based on the graph, what does the graph look like based on this model? It's a parabola that opens upward. So it makes sense that it is asking you to find the minimum average height. If you are looking for the minimum average height and the graph represents the height, what is the minimum on the graph? Your vertex. That is your vertex. Your vertex is your minimum. Okay? Now, while you're finding your minimum height, at the same time, I need to know what the corresponding row spacing is. Okay? Now, that test stops there. I'm not giving you step 1, step 2 on the test. You have to know to do this. So if you're asked for the minimum average height, you should know you're looking for the vertex. Again, I'm not going to tell you on the test what these values are. You need to be able to recognize them. From there, you should be able to determine the x value of your vertex. It is negative b over 2a, which is negative 1.28 over 2 times a. Get your calculator out. Tell me what that is. You'll have to do this tomorrow.
26.6
Thank you very much. 26.67 centimeters, right?
Yes, ma'am.
Okay, I need units. Now, in addition to that, we have just found the row spacing, but I'm not asked for just the row spacing. I need to know the corresponding average minimum height. So I need to find the y value. So I'm just substituting this in and evaluating h at r. So what is that? H of r. That's h of 26.67. What is the output? Anybody?
Wait, so
I'm just taking this equation and I'm substituting in 26.67 for r. It's a V for the vertex. Yes, Matthew, I hear everything. Did anybody get it?
16.53.
That is absolutely perfect. Okay? So now I have my vertex.
wait, so what does that number represent?
Tell me.
H Y value of the vertex.
Y-intercept?
That's the y value of the vertex, but in the context of the problem, what does this represent?
So oh, it's the minimum value.
The minimum average height. So since this is a word problem, we're writing our answer in a complete sentence. The minimum average height is what?
16.53 centimeters.
Thank you.
Wait, so what is 26.67?
Well, what is 26.67?
What?
What is it?
That's the
R?
vertex.
That's the x value of the vertex, but what is that telling you in the context of the problem?
How far
The
apart?
distance
This should
between-
be-
Yes, when the rows are spaced 26.67 centimeters apart. So on the test, I'm looking for a sentence. I'm looking for you completely answering my question, including the values and the units of measure. The answer itself, not even the work, is worth 5 points. So if you don't write a complete sentence, you don't answer the question, you don't write the units of measure, you're losing points for each of those. Okay? So you do have to be able to read it and understand what you're finding. Okay, next example is a football example. Okay, the height and feet, the height can be modeled by this function. So that means my output is my height. It is modeled by this quadratic function. Now, based on the graph, bless you, what does the graph of this function look like?
Negative.
Opens down.
It opens down. So I have a little person here who's about to kick a football. Okay? There's the little ball. He kicks the little ball, it comes up, and it comes back down. So the trajectory of the ball is parabolic in motion. Okay? Now,
Dr. P, it's not a very good time.
I'm sure it's better than how well some people will do on this test tonight. Okay?
Probably true.
Okay. X is the horizontal distance, so that means X is this distance here. Right?
Mm-hmm.
It's distance in feet. Now, based on the model, I am looking for the maximum height of the punt. So if I'm looking for the maximum height of the punt, what point on this graph am I looking for? I am looking for the vertex. That's basically what it comes down to, right? Now, I have the equation. I need to figure out what is the maximum height of the punt and how far from the point of impact does this occur. What is A?
Negative 0.01.
What is B?
1.18.
Let's substitute in and let's find the x value of the vertex. Anybody?
59.
59 what? Feet. And what does that represent?
The maximum height.
No, it is not.
Oh, wait, no.
It is the horizontal distance. X is the horizontal distance. So I know that the maximum height is going to occur 59 feet away. Okay, y value. Let's substitute in 59 for x. And tell me what is the maximum height. No.
36.81.
Yes, feet, right? So we're writing the answer to a word problem in a sentence. You would say the max height of the punt is 36.81 feet and occurs 59 feet away, bless you, from the punt, or kick, or whatever you want to call it. Are we good?
Wait a minute. Why did you say like 59 feet away from the punt?
Because once he kicks it, this is the horizontal distance, right? Okay, now I want you to go to the word problem. It's in 3.1 after the graphing of the inequalities. Find the little community garden. You
So
ever
if we did that without showing any work, we wouldn't be able to get it.
Well, I mean, what I would like to see, I mean, you should be able to do this, right, and then put it in the calculator. You should be able to show me what you're evaluating and then put it in the calculator. But let's say you wrote me a sentence and these are both wrong. If you don't show me any work, I can't give you any credit.
Because what if we graph it in the calculator and just look for the maximum? Like with the maximum.
I'm gonna tell you that perhaps you're not always looking for the vertex.
But like for this problem.
If you were looking for the vertex, sure. But if you get it wrong, then there's no work.
Yeah.
There's no partial credit. Okay, can we look at our little rectangular garden? Okay, so here we have a rectangular lot.
38.
We have a rectangular lot. There's my little rectangular lot. It's being turned into a community vegetable garden.
Oh, it's 38.
Measuring 15 meters by 12 meters. So I drew the rectangle. I like to see pictures. It helps me.
Yeah, 38.
I know the dimensions of my little garden. Now they're also telling you that you are putting a path of uniform length surrounding the garden. So I have a path surrounding the garden. That path has a width. I'm going to call the width of that path. This is X. All the way around, right? This is all X. This is X. This is X. You see what I'm saying? I'm adding a uniform length path around the garden. Does that make sense?
Yeah.
Okay. Now, if the area of the garden and the path, oh, okay, so now I'm enclosing and I'm looking the area of this whole thing. Well, if the area is 378 square meters, and I know it's length times width, I need to know this length with the width, with the path, and this width with the path. So what is this new length?
That length plus 2 times and then added.
Okay. So 15 plus 2x, 15 plus 2x, right?
Yeah.
And the width of this?
12 plus 2. Wait, why 2x?
Because I have an x here and I have an x here. On either side. I have 15 joules. I have 15. I have 15 plus an x plus another x.
Yeah.
Okay, so now I can rewrite this as 15 plus 2x times the new width 12 plus 2x. If I'm solving for x, what do I do? I'm going to FOIL the right-hand side. Okay, FOIL it and tell me what you get.
Oh, 180. 180 plus 54x plus 4x squared.
I agree. This is just a quadratic equation, so what do I do next? Okay, well, I need to move this over, right? So what would that be? Minus?
Minus.
Yeah. Now, there's a couple ways we could do this. We could immediately jump into the quadratic formula, or we could try to factor it. We could get the greatest common factor. We could split the middle. I don't care how you find it. Tell me what the width is.
Wait, why did you subtract? Oh.
Set it equal to 0. You all find x right now. I don't care how you do it. Find it. Whatever method you want. Tell me when you get it. Anybody get it?
How would you do this one?
Me personally?
Or am I missing something? Yeah, how would you do it?
I would factor out a greatest common factor. So I would take out 2, giving me 2x squared plus 27x minus 99. I don't know, divide both sides by 2. giving me 2x squared plus 27x minus 99 equals 0, and you could either use the quadratic formula or split the middle. I would split the middle because I can do it. So I would split that as plus 33x minus 6x equal minus 99 equals 0, and then I would factor by grouping. So I would take out an x, and then a negative 3. And then I've got x minus 3 times 2x plus 33 equals 0. So I've got x equals 3 and x equals negative 33 over 2.
And it has to be x equals 3.
You are correct. So this can happen because x represents the width of the path, and the width of the path has to be positive. Were we able to get 3?
Yeah.
And more in particular, 3 meters. Right?
And like on the test is when we can use whatever method.
There's quite a few where you can use whatever method you want. Okay, before I do the next 2 word problems, I would like to go back and talk about how we graph the quadratic inequality. Yeah, we're using the same idea of graphing a parabola. The only difference is instead of an equal sign, in just having the parabola, we have an inequality. So that means we have a less than or equal to, a greater than or equal to, a less than or a greater than. So that means we have to pay attention to the boundary. If the boundary is or equal to, the boundary is solid. If the boundary is just greater than or less than, then the boundary is dotted. Okay, so we do have to pay attention to that now. And then after that, we have to choose a test point so we know whether or not we are shading the inside or the outside of the parabola. We've already graphed inequalities in the past. We graphed linear inequalities in the past. So we just chose the test point, see if it satisfied the original problem, and then shade it accordingly.
Is linear inequalities again?
Yes, this is over test. Okay, so let's take a look at how we would do this. If you are given this linear inequality, the first thing that you want to look at is the boundary line. What can you tell me about the boundary?
It's solid.
The boundary is solid. Okay, what else can you tell me about the parabola?
It's
It
positive.
opens up, yes, because A is positive. What else can you tell me?
Wait, so do we need to know the term opens up
No,
and opens
no.
down?
No, but you need to know what it means.
Oh, I understand.
Okay, from the inequality, what else do I know?
Oh,
Vertex
Y-intercept.
What is the Y-intercept? So help me God, if you write 12 on the test, you don't get credit.
Yeah.
It is a point.
That's
You will get-
confusing because
you
in
will
my math
lose.
lab you just put 12.
Huh?
On my math
I know,
lab,
my math lab is sloppy, I've already said that.
yeah.
I don't like it, but I can't control that. I can't override it. Okay, so I know my Y-intercept, I'm gonna plot it. Now, what was the next thing we looked for when we tried to graph a parabola?
The vertex.
The vertex. So what is A?
Is
What is
A is
B?
1, B is negative 8, and
So to find the x value of the vertex, I substitute into negative b over 2 times a. So what is the x value of the vertex? Okay, what else do I have to find?
The Y value.
Thank you. So I'm just evaluating the function when the x is 4. So what's the y value of the vertex? Yes, -4. So now I can plot my vertex. Now on the test, you are showing me the vertex, you're plotting the point, I need to see the point, but you must label it. If you don't label your graph with all the critical values, you will lose credit. Now, at this point, I also know another property.
The axis of symmetry.
I know the axis of symmetry. What is the axis of symmetry?
X equals 4.
Beautiful. If you do not write it as an equation, you lose credit. You need to plot it as a dotted line and label it on your graph. If you forget to do any of this, you lose points. The graphs are heavy duty. They're worth about 13 points or more.
Per graph.
There's 2 graphs. Now, what else do I possibly know now that I know the yes, Jackson?
Wait, Dr. B, is calculator tomorrow?
Calculator's tomorrow, but I will tell you, just because the calculator is tomorrow doesn't mean there's other problems that are non-calculator, but you may want a calculator for arithmetic, so I put them on there.
Oh,
Okay.
No
All right.
other point.
Yeah, I do. What is the other point? Do I know another point? 812. I need to see that third point on the other side of the axis of symmetry on the test. Now, what other critical values might I want to know about this parabola? The X-Intercepts. How do I find the X-Intercepts?
Substitute.
For Y. Factor that. Tell me my 2 factors.
Negative.
I need the factors.
-2.
X minus 6 and X minus 2.
So wait, how'd you get that Y-intercept? You just plugged it, put in 0 for,
Yes. It's always the constant.
Why couldn't you just draw the graph and then see that x was at 62?
Well, because if you're sloppy, God only knows what your graph looks like. And what if they're not integer values? Because you're going to have to tell me what the intercepts are on the test. So you have to actually find them. Good question, but you have to actually find them. All right, so I know this and I know this. If I don't see those X-intercepts, if they're real, I better see them on the graph.
Wait, what if it's like non?
They're going to be beautiful numbers. They're going to be beautiful numbers. Okay, you said that
Beautiful numbers, you get beautiful numbers.
they're beautiful numbers. You'll be happy. Okay, we said it was solid, right? How do I know where to shade?
Substitute 0, 0.
Okay. So if I go back here and substitute in 0, I get 0 is greater than or equal to 12. Is that true?
No.
False.
it's an inside the shade.
Yeah, 16 minus 12.
And you have to have like the arrows on each side of the graph.
That would be
Wait,
nice
do you-
to just one.
Oh, wait, what? Wait, do we have to have the arrows? Or?
Put the arrows, Jackson.
Wait, if it's false, you shade the graph?
Well, we tested 0, 0, but 0, 0 was false, so I can't shade the region that has 0, 0.
But that's not,
Only time you don't choose 0, 0 is if the boundary goes through 0, 0.
The boundary of the 0, 0.
Let's try one more, because graphing is so important. What do I know?
You know the Y-intercept?
Okay, what is
And
the
that
Y-intercept?
it opens downwards.
I do know it opens down. What else do I know?
That
It's
it is
dotted.
a dotted line.
Okay, so 0, -7, there I am. Now what?
You solve for the vertex.
Okay. What is A? B? So what's the X value of the vertex? What's the Y value of the vertex?
We mentioned that.
Make sure you label your vertex when I ask for it as a point. So -1, -4. And we said it opens down. Okay, it's looking good. It's looking good. What else do I know? Okay, what's another point? Okay. What else do I know? Okay. Make sure that it's rounded and it doesn't look like an absolute value function. I'll take off of that. What else?
What part is round?
This.
You shade
There's more. There's more to this graph.
the axis.
Okay, Okay, what is the axis of symmetry?
Oh, wait, Dr. B.
No, it's an equation.
Wait, Dr.
X
B.
equals nothing.
Yes, Jackson?
Do you have to show your work for the, like, the left orange point that you wrote?
No.
And label your axis.
Thank you very much, Jules. You see how many points you could lose?
Yeah.
Okay, now, last but not least, where do I shade?
Oh, wow, hold on, 0, 0.
Dr. B, question. So, when you were given the test, will our question look like that, like just to graph that, and then we'll have to fill it all that in, or will there be like blanks for us to?
There's gonna be blanks.
Okay.
For the one where I ask it, there's gonna be blanks, but there is gonna be one like this that you just have to graph it, and so I'm gonna need to see all this, but I won't need to, necessarily see that.
So do we need
Okay.
like circle or box diagrams?
Well, no, because there's gonna be fill in the blanks, right? But if I ask you to just graph something, you're gonna have to do work to be able to label the vertex, stuff like that. All right, now, I'm gonna go over the next thing ever so briefly. It would be a disservice for me not to show it to you, but it is not on the test
Oh.
proper.
It's not on the test.
Wait, are we going bell to bell today?
Yes.
Study or like learning?
Well, it depends. Some classes have gone down to bed, some classes have had like 30 minutes of it. All right, so let's take a look at this. We know when we have a parabola, if we're in 2 dimensions, right, we look for roots and then we shade, right? Well, what if I give you the quadratic equation, but I don't see the second dimension? In other words, I've only given it to you in terms of one variable x. Well, I know what this really is in 2 dimensions. It's something that looks like this, right? Depending on where we shade. So what I can do is I could turn this into an equality and I could solve for these critical values. So if I take this inequality and turn it into an equality and then set it equal to 0, I could then factor. So what are my 2 factors? That is on the test.
X minus 7 and X minus 3.
Okay, so my critical values are x equals 3 and x equals 7, right? Since this is an or equal to, I know that they really do exist, okay? It is a solid boundary line. Now, instead of going through the process of graphing and test points and stuff like that, there is another way to do it algebraically. I look strictly at the number line, and I divide my number line in 1 dimension into 3 intervals. Here are my 3 intervals. So I would make maybe a little chart where I have my intervals. My first interval is -infinity to 3. My second interval is from 3 to 7. My third interval is from 7 to infinity. So I have 3 intervals. Then within each of those intervals, I can choose a test value. So in other words, I could choose like 0. And if I substitute 0 in here, what am I going to get? I'm going to get 18 is less than or equal to -3. Is that true or false? That is false. So that means I am not shading here. Now, knowing what this really represents in 2 dimensions, I know that if I don't shade here, I don't shade here, and I'm shading here, right? Yes. So I know technically this is false and this is true. So my solution is only this, which corresponds to this in 2 dimensions. So how would I graph that algebraically? Well, it would be on the number line, and I could either represent the solution set as a closed interval or as an extended inequality, depending on how it's asked.
So,
Are we going to go over this more now?
No,
what is this for?
solving a quadratic equation in 1 dimension algebraically.
And this will be on the test. It won't be on the test?
It will not be on the test proper.
Wait, but
There's a practice.
That sounds like a bonus question is going to be over that.
So shall we move on to quadratic regression?
Well, I don't get that.
Well, then you won't get that bonus. All right, get your calculators out. Let's see how much you remember from linear regression.
What page?
I love that.
What is that called? Graphing what now in the 2 dimension? That's Where is it, where was that in our notes packet?
Right after what we just did.
I don't think it is.
Yes, it is.
It's on page 36, Rob.
Okay, so let's get our calculators out. Do you remember how to enter data
Yes.
into your calculator? Where do you go?
The stat button.
Stat.
Okay, you see this word problem? How many lists are you entering into this word problem?
4,
No.
2, 2.
Yeah, you have an input and an output, right? You go to stat, you go to enter, you enter in those lists. You need to be able to interpret the data that I have given you. I have given you miles per hour and the speed, and I've given you the fuel economy. I can represent that data however I want. But there's only 2 lists of information in there. Be careful as you enter in your lists. Once you enter in these lists, see if you remember how to create a scatter plot. One thing I will be checking on the test before you start the calculator portion is that these lists are empty. So how do we erase the data in this list?
Stat, edit, and then you just clear.
Okay, so you can highlight the list name, you can arrow up to the list name, and you can hit clear. Please do not hit delete, because if you delete the list, you have to reinsert the whole list.
Wait,
Okay, so just highlight and hit clear, not delete. So we're entering in the lists. I will also be checking to make sure that you have no equations in your calculator before you start, so that will throw you off. Once you enter this data into 2 lists, see if you remember how to create a scatter plot. Lucy, why are we not doing this on the calculator? The test is tomorrow. This is on the test. You may not share calculators during the test. You have to have your own calculator. Okay, do you have your list in there? Did you create a scatter plot?
Plot, Y1, Y2. And do that.
Does everybody put their lists in? Yes? Speak now?
Nope.
No. Okay. When you do enter in your lists, right, you can go to second Y equal. Second Y equal allows you to turn your plot on. Second Y equals. Make sure your plot is on. So you have to hit enter. Make sure that you are plotting the correct values in the correct order. So your independent variable X is in your list 1. Your dependent variable Y is in your list 2. If you remember when we did the shoe and the height, we did a lot of lists and we had to change the order. So if it's out of order, I'll give you the wrong graph. Then to see the scatter plot, make sure that you have no equations in Y equal. You can also check here that your plot is on.
What?
Make sure your plot is on. Make sure you have no stray equations.
We want to
Wait a minute, are we supposed to graph all this?
Scatter plot. We're graphing a scatter plot right now.
I asked him, but are we supposed to do every single one of these numbers in one equation, or just 2?
I don't know what you're
It should be
saying.
a table, not an equation.
So it's like we graph these 2, the first 2, the first X
No,
and
we're gonna
Y.
get the average.
You put the whole list in there.
Oh, this is continued?
Yeah.
Wait, so for speed X, you put the first table in there and then the second table after it in the same.
X is X, Y is Y. It's really a lot of information, so I separated it into 2 different rows.
Oh, I asked now.
Okay? Once you enter in all your data, you turn on your scatter plot, you graph it. Now, why would we want to do a scatter plot? Well, because maybe at the end of the year, I'm going to give you a bunch of data and you have to figure out what is the best regression model to do. Is it linear? Is it quadratic? Is it exponential? Is it logarithmic?
Wait, what
Is
is
it, I mean, there's so many that you're looking at this and it looks like a little parabola opening down. Jules?
I don't see it.
Why might you not see
Do I need to
it?
fix my
You
window?
gotta fix your window. How do we fix our window? We go to window.
So,
How do we know what values to put in there? Look at your data.
can we get a linear regression from this, but
Yes, but it would be wrong. It would be bad.
we can't get a quadratic linear regression?
You're either quadratic or linear. You can't be
I mean,
both.
a quadratic regression?
That's what we're doing. Okay? So first things first, do you see your data, Rob?
Oh, I found it.
Fix your window.
I just figured out the quadratic regression.
Okay? So now you have your graph. But now I want to calculate a quadratic regression. Do we remember how to do that?
No.
We go to stats. And instead of editing lists, we are now calculating something. Which one do I go to?
We want to go to
Five.
calculate.
Hey,
Quadratic regression.
wait.
So select quadratic regression. Make sure that you are performing your regression on your correct list. Okay? Then we need to store that regression equation. And y equals. Do we remember how to do that?
Yeah.
Vars.
Wait, what?
Whoa.
Oh, that's cool.
Wait, what'd you put?
Vars.
I saved it.
I'm saving it as a y variable. That is a function. Where do I want to store it? I don't care what you put in. I'm putting it in y1 because I don't have anything else there.
Already have to.
Wait, how do we put this in there?
Oh, it tells you.
Okay? Now, look at your notes. Your notes, I gave you A, B, and C. You need C. I mean, A and B, you need C. Right? Write that in your notes.
Wait, Dr. B, I don't know how to do this.
Lord help, Jackson.
Okay.
Okay, y'all. On the test tomorrow, I will tell you. Nobody's listening.
Everyone be quiet. We leave a test tomorrow.
Let's let them figure it out.
Oh, thanks, man.
On the test tomorrow, I will tell you to write the equation in standard form. You need to be able to take this information and write the standard equation.
It won't go away now.
Okay, hang on, Jackson. I will also tell you to what place to round it. Unless it's money, in which case you should know you round it to 2 decimals. Okay? Now, we have this model. We can answer some questions. So if we go back to our notes, bless you. It is, yes,
Is it bad if we got different numbers too?
yes.
This is wrong. That's L3.
There is only one. Do you have all your data in your list?
I think so. It's like close, kind of, but not the same.
No, I mean, it really has to be exactly the same. We have the same
Yeah,
data.
I don't know where I got it from.
That.
Hey, check your data.
Mine's off
The
too.
other one.
It shouldn't be.
What'd you get?
13.7.
So
What's
Okay.
the formula for doing a quadratic regression?
What do you mean the formula?
Wasn't that like a formula for linear regressions?
The equation of a line. It's so Intercept form. All right. Now, let's go back to the notes and let's talk about how we're going to answer this question using the calculator tomorrow. It says, at what speed would you get the highest fuel economy?
Ooh, let's look at our table. 40.
So, let's look at the graph, right? You've stored your equation. We all see the little quadratic model passing through some of those points, right? You see it? Now, is there a way for the calculator to calculate the
Oh, wait.
maximum height? I mean, the maximum fuel economy. What point is that? It's the max, it's the vertex. So go to second trace. What do you think we're doing?
Maximum.
Maximum. Now, what does the calculator need to calculate it? It's going to just go anywhere on the curve. And notice what it's asking you. It's asking you for the left bound. Go to the left of the vertex. I don't care how far you go, just go to the left of it. Hit enter.
Oh.
Then it says, what is the right bound? Go past the vertex, I don't care where, Hit enter. You are telling the calculator, look in this little neighborhood and find me the maximum. There it is.
When you just click enter?
Yes. So how do we interpret that information to answer this question?
So, what is the maximum speed? And then the X's are, so 45,
Get like
4, 9, 8.
What is, interpret the data. What is this telling you? This is telling you that you get the maximum fuel economy of what? What is the max fuel
The
economy?
max fuel economy you can get mile per gallon is when you're going 45 miles per hour.
And the maximum fuel economy is
30
miles per gallon. You have to be able to answer these questions.
Do you
Right?
want, like, complete sentences that you do?
Yes,
I
this
did
is
do it
work,
wrong. I did the
yes,
same thing.
yes. Okay, are we all right with that? Okay, let's now go back to these word problems.
Let's go.
So you see like the maximum fuel economy is 30 at
30 miles per gallon, I need units.
They won't like straight.
Okay, are we ready? Here we go, here we go.
what do you say 30 miles per gallon at 40?
I don't know, what is the maximum? I've already disclosed mine.
You
Rob,
just
sit
say at
down.
45
Rob, we've got a lot more to do and we don't have a lot of
Are
time.
you serious? We
Yes.
got more?
Yes, we have two huge word problems.
Good.
All right, here we go. Let's interpret the information. You've been given a picture. A ball is thrown upward from the top of the Leaning Tower of Pisa. So somebody's standing here, they're throwing a ball and it comes up and then it goes back down. We know the height of the Leaning Tower of Pisa. So when I'm standing on top of here, I'm 190 feet off the ground. Now, so it gives us some other information.
Dr. P,
Yes,
how do you know what part of the tower you're standing on?
I'm at the lowest part. That's the way
Like,
to
wouldn't
do
you
the
be
picture.
falling off the edge?
Nope.
It's not.
All right, I have an initial velocity of 96 feet per second, so let's keep that in mind. It's asking me during what time period, so I'm solving for time. It's saying at what time period is the ball's height higher than that of the tower.
That looks like a piece of
Okay.
question.
You have been given this equation. So let's make sure we understand this equation. How many people in here have had physics?
0.
Okay, so Emily, you should know this. S stands for position. Why? It's kind of a long story. I'm not going to get into it. I'm happy to discuss it, but it's based on derivatives. So it's calculus. This is position. The position at time t is -16 is the gravitational constant for a free-falling object. It's given, it's known, we're on Earth, here it is. That's why they give it to you. Times t squared plus v with this little subscript of 0. So what does this little subscript of 0 tell us? What does that mean?
It's velocity number 0.
Exactly, it's our initial velocity, a velocity at time 0. So v naught, subscript of 0, is my initial velocity. Times time equals, what do you think S naught is?
That
Final
is height.
position.
Not final.
Or
What did I just
starting
say?
Wait, it's height.
Initial position, initial position. So let's write into this equation everything we know. So S of t equals -16 t squared plus, do I know v naught?
Yes, ma'am, yes you do.
It's 96, yes, times t plus, do I know S naught?
Yes, ma'am.
190, right? Now, I'm looking for when this exceeds, well, exceeds the height of the tower. So it must be greater than what? That's the inequality you are solving. I'm solving for time. This is going to give me the interval for where the ball is above that of the tower.
Okay.
How do I do it?
Can we solve it ourselves?
Go for it. Go ahead. Y'all do it.
Okay.
So I can turn this into an equality and solve for the two t's.
Oh, that works out great.
It does. Go ahead.
It seems like a real
Go
unrealistic
ahead.
problem.
Go ahead. No, it doesn't. It's supposed to be this.
When am I ever going to throw a ball off the Leaning Tower of Pisa?
Well, you may not be asked to throw a ball over the Leaning Tower of Pisa, but you may be in a position where somebody asks you a question that you have to problem solve, and you take the information you've been given and substitute it into a formula to answer their question.
So Wait a second.
Whoa.
Whoa.
Jackson, is that what you got?
Yes, ma'am.
Okay, so what can you tell me is the answer to this question?
It's 6.
No.
Oh,
The ball exceeds the height
wait, the ball
of the tower. When?
is 49.
When?
The ball exceeds the height of the tower at 6 seconds.
No. This whole time it's above the tower.
Through the time period of 0 and 6.
Between 0 and 6 seconds.
So you have to think about it on the second dimension.
So is that until it's, wait,
So right here, I throw it up, it's above the tower. It's above the tower, it's above the tower. 6 seconds later, it's now falling below the tower. All right, now, this next problem. This next problem is a little bit intense. A little bit intense. Meaning it has things that you need to be able to do on the test, but this one is a little bit long for the test. So the skills that this is reinforcing is being able to solve equations that have radical expressions in them. Here is practice.
That's gonna be on the test?
Yeah. You know, there were a lot of things that I was hoping to not put on the test because y'all got it on the quiz, but you didn't get it on the quiz, so it's back on the test.
Wait, Dr. P, can we get our quizzes back?
So, yeah, they're in the back. So, what's on, not now, Jackson, we need to do this problem. So there's this. And on the back, yeah, let u equal. Yeah, that's back on the test too.
Wait, what
Okay.
is?
So make sure you get these before you leave and practice. Now, let's set this up. I haven't made one yet.
No, shut up, I'm gonna blow you through that. No.
Okay, I'm gonna set this up, but I don't know if I'm necessarily gonna work the whole thing, because, you know, I just don't know. We'll see. I have the answer to this one.
You do have the answer?
To this one, yes.
You
I
should
just
give it
worked
to
it
us.
6 times, and I'm a little tired of it. All right, let's read it. We have 2 towns. We have town A and town B. Here's A and B. Rob, please. They are located 6 miles and 3 miles respectively from a major expressway. Does that make sense so far? Okay. Now, the point on the expressway closest to A is 12 miles away from the point closest to B. So far, so good still? All right. Now, they are building 2 new roads, from A to the expressway and from B to the expressway. They have some length. I don't know the length. I'm going to call them D1 and D2. We want to express the combined lengths of the new road in terms of X, given that the combined lengths of the new roads equals 15 miles. So the length of D1 plus the length of D2 equals 15 miles.
Right.
Okay, so let's think about how we're going to represent D1 in terms of some known value X.
Wait, how do you know it's 15 miles?
Because they just told me here.
Oh.
Okay, now the key is looking at how I'm representing this length. There's a piece here. There's a piece here. If the whole thing is 12, then, well, I don't know. I didn't say it was half and half.
Oh, this looks
It
geometry.
is. So at this point, I can represent one piece as X, and then the remainder is that whole length 12 minus whatever this X is.
Are you saying things like the 15 miles?
Well, now I have to figure out how I'm going to write D. 1 and D2, right? Because I eventually need to substitute in here. Can you tell me how I can write an expression in terms of X that represents the length D1?
Oh.
What is that shape?
Oh, A's,
Oh, my guy,
X squared plus.
Pythagoras theorem.
Pythagorean theorem, okay? So D1 is the hypotenuse, so I can say D1 squared equals 6 squared plus x squared. Do you agree with me?
Yes.
Okay, so d1 squared equals 36 plus x squared.
Wait, why X?
Well, a squared plus b squared equals c squared. Are we okay?
Yeah.
Okay, so then if I really want to just know what d is, d1 is the square root of 36 plus x squared.
So 6.
No,
Oh, wait, why?
because that is a binomial.
Yeah.
You cannot square root them separately. That's not a product, that's a sum.
What?
Did anybody read what I sent?
No, I couldn't find it. I looked for it for like.
Somebody sent it to
So it's
Rob.
on canvas.
I know. I
Okay.
looked at Canvas.
You need that.
Go to your inbox.
All right, can we write D2 in terms of the lengths of its sides using the Pythagorean theorem?
Wait, so we leave it like that? This
D2
one is
squared plus is equal to 9 plus x. Oh, 12.
100% did that on the quiz.
What is D2 squared? 9 plus what?
144 plus 24x x squared.
Minus
Minus.
24x.
You with me?
Yes.
Okay, so now I have D1 and D2. I can come back here. Then I can write D1 plus D2 equals what? 15. I need to solve for x. What do I do?
You isolate.
Yes.
Square both sides.
Yes, yes.
Is there a reason that you chose that equation over?
No. You can do either one.
X
X squared.
Okay, now you said square both sides. So that gives me 36 plus x squared equals, what is the right hand side? You have a calculator. This is a calculator problem. What is it?
205.
Bless you.
Minus 30 square root here. Plus,
That was 100.
yeah, then x squared.
Mercy.
Now what would I do?
Isolate
Yes.
the other
That
one.
one.
So what does that give me on the left hand side?
30s.
So this is 30, well, negative.
Yeah.
And what is over here on the left?
Negative 189.
What is it?
Oh,
Negative.
342.
Mm-hmm.
This x is canceled.
Yeah. Then what?
Divide by 30.
No, you don't want fractions. Square both sides.
No.
So is that
Okay, so FOIL on the left hand side, what do we get? You have a calculator.
oh, total.
Wait a minute.
Well, I didn't want to ask.
Never mind.
Hmm?
Never mind.
This is a huge number.
Here it is.
So we should be expecting huge numbers on this test,
No, I didn't say that.
but we should.
Or negative 1.
You should be able to do each of these steps. Maybe not all together, but you should be able to do each of these. Okay, then you would have to distribute, I'm just gonna walk you through it. You distribute, just numbers,
Just math.
just numbers. Okay, then you get everything on one side.
Did you memorize this?
I've done this 6 times.
No, that's fair, that's fair, that's a fair point.
I know. That's not gonna be wrong. Is it good? I would.
Then you should be able to get x equal 8. Which is the least. Okay, your quizzes are in the back. Make sure you understand everything that you missed. You will see those problems again.
Dr. P, this class has driven me to the extreme caffeine